It seems like a simple question, right? What is a human? You might point to yourself or to the person next to you. We all kind of know what a human is, or at least we think we do. We walk upright. That's how we talk, we build things, we think deep thoughts, we have feelings. But if you ask scientists, especially those who spend their lives looking at bones, tools, and genes from millions of years ago, the answer gets a lot less clear. And no, they absolutely do not all agree. Not completely. It's messy. And that's okay. Science often is. It's not about finding one perfect answer that everyone stamps their approval on. It's about asking good questions and trying to piece together the truth from incomplete information. When it comes to what makes a human, especially when we think about our deep past and how we got here through evolution, there are lots of blurry lines and honest disagreements. Think about it this way. When you look at a baby, you know it's human. When you look at an adult chimpanzee, you know it's not. The difference seems huge, but what about the things in between? What about our ancient ancestors? Where exactly did the human club begin, and what are the rules for joining? For a long time, the simple biological definition for modern humans has been Homo sapiens. That's our species name. It means wise man. It sounds pretty clear cut. We are Homo sapiens, and everything else is not. But then you start looking at the fossil record, and things get complicated fast. We share a genus, Homo, with several other species that are now extinct. Think of it like this: a lion is Panthera leo, a tiger is Panthera tigris. They are different species, but they are both in the Panthera genus. They are related. They are both big cats. In the same way we are Homo sapiens, and there were others like Homo erectus, Homo habilis, and Homo neanderthalensis. Are they humans? Some scientists would say yes, they are all part of the Homo lineage, so they are all humans in a broader sense. Others would say no, only Homo sapiens are truly human, and the rest are just close relatives. This is one of the biggest points of contention. Let's start with the very basics. What makes Homo sapiens distinct? Well, we walk on two legs, a trait called bipedalism. Our brains are really big compared to our body size. We use complex language. We make complicated tools. We have culture and art. These are some of the things often listed as defining features. But here's the rub. Many of these traits didn't just pop up all at once. They evolved gradually over millions of years. And many of our extinct relatives had some of these traits too. Take walking upright. Our very early ancestors, like Australopithecus, were already walking on two legs over 3 million years ago. But most scientists wouldn't call an Australopithecus a human. They are generally considered early hominins, stepping stones on our evolutionary path, but not fully human in the way we usually think of it. So bipedalism alone isn't enough to define a human. What about a big brain? The Homo habilis, often called handyman, because they made simple stone tools, lived about 2.4 to 1.4 million years ago. Their brains were bigger than Australopithecus, but still much smaller than ours. Were they human? Some scientists say yes, because they were the first species placed into the Homo genus. They started making tools, which is a big deal. It suggests more complex thinking. But others might argue their brain size wasn't quite human enough, or their tools weren't complex enough. Then came Homo erectus, around 1.9 million to 110,000 years ago. These guys were really important. They were the first hominins to leave Africa and spread across Asia and possibly Europe. They had even bigger brains than Homo habilis. They made more sophisticated tools, like the teardrop-shaped Acheulean hand axes. They might have controlled fire. That's a huge step. Many scientists are comfortable calling Homo erectus human, in a general sense, because they showed so many of the traits we associate with humanity: upright posture, bigger brains, complex tools, adaptability. But even then, their brains were still smaller than ours, and their culture was probably much simpler. So, still not exactly us. Now we get to the really tricky part: Neanderthals. Their scientific name is Homo neanderthalensis. They lived in Europe and Asia from about 400,000 to 40,000 years ago. They had brains that were actually larger on average than modern human brains. They made sophisticated tools, hunted large animals, used fire, wore clothing, and buried their dead. Some evidence even suggests they created art or jewelry. They cared for their sick and elderly. Sound familiar? This is where the debate really heats up. Are Neanderthals human? Biologically, they are a distinct species from Homo sapiens, but they were incredibly close to us. Genetically, we know that Homo sapiens interbred with Neanderthals. Many people of non-African descent today have a small percentage of Neanderthal DNA in their genome. This fact that we could successfully interbreed complicates the traditional definition of a species, which often states that two species cannot produce fertile offspring. If we could, does that mean we were the same species after all? Or just very, very closely related, like a horse and a donkey, which can breed but produce infertile mules? Some scientists argue that because they interbred, Neanderthals should be considered a subspecies of Homo sapiens, perhaps Homo sapiens neanderthalensis. This would make them fully human, just a different kind of human. Other scientists strongly disagree. They point to distinct anatomical differences. Neanderthals had different skull shapes, brow ridges, and stockier bodies adapted to cold climates. They argue that successful interbreeding doesn't automatically merge two species, especially if the offspring had reduced fitness or fertility, which might have been the case for some Neanderthal sapiens hybrids. So, for them, Neanderthals are a separate, though very close, species of Homo, and thus not us. It's not just Neanderthals. We also know about Denisovans, another group of archaic humans who lived around the same time, and also interbred with Homo sapiens. We know less about them because we have fewer fossils, but their genetics tell a story of intermixing. So, the picture of our past isn't a neat, straight line where one species turns into the next. It's more like a tangled bush, with different branches living side by side, sometimes interacting, sometimes merging a bit, and then some branches dying off. So when scientists talk about human, they might mean different things. A lumper in anthropology is someone who tends to group many similar fossils into one species. They might say that Homo habilis, Homo erectus, and even Neanderthals and Denisovans are all part of a broader human family, or perhaps even just one very variable species of Homo. For a lumper, the differences might not be significant enough to warrant entirely separate species classifications. A splitter, on the other hand, sees smaller differences as significant enough to classify fossils into many different species. They might argue for a finer grained categorization, seeing Homo habilis as distinct from Homo erectus, and definitely seeing Neanderthals as a separate species from Homo sapiens. For a splitter, the evolutionary trajectory is one of distinct populations diverging into new species. Neither approach is inherently right or wrong. They are different ways of interpreting the evidence, and both have their strengths and weaknesses. Lumpers might miss important evolutionary divergences, while splitters might overemphasize minor variations. What about defining human, not just by bones, but by behavior and mind? This is another huge area of debate. When did we start to think like us? When did abstract thought, symbolic communication, art, and complex planning truly emerge? For a long time, many scientists believed that only Homo sapiens were capable of behavioral modernity. This meant things like creating art cave paintings, figurines, elaborate burials, personal adornment jewelry, advanced tool technologies like blades and projectile points, and long-distance trade. These are often seen as hallmarks of a fully human mind. The earliest undisputed evidence for these behaviors comes from Homo sapiens in Africa, sometimes as far back as 100,000 to 70,000 years ago, and then more abundantly in Europe during the Upper Paleolithic around 40,000 years ago. For a long time, the idea was that Homo sapiens underwent some kind of cognitive revolution at this point, becoming truly modern humans. But this idea is also being challenged. More and more evidence suggests that Neanderthals, and possibly other archaic humans, also engaged in some of these behaviors. For example, Neanderthals made jewelry from eagle talons and shells. They used pigments. They cared for their injured and buried their dead, sometimes with grave goods, which suggests symbolic thought and perhaps belief in an afterlife. The complexity of their hunting strategies and tool-making also points to significant cognitive abilities. So, if Neanderthals had brains as big as ours, made sophisticated tools, hunted in groups, buried their dead, and maybe even made art, how unhuman were they really? If the definition of human includes these cognitive and cultural traits, then where do we draw the line? Did these traits evolve gradually across the Homo genus, or were they a sudden invention of Homo sapiens? Scientists still argue about this. Some say Neanderthal art was rudimentary or accidental. Others say it shows clear symbolic intent. The evidence is often sparse and open to interpretation. Another huge factor is language. Complex language with syntax and grammar is often considered a defining human characteristic. It allows us to share incredibly complex information, plan for the future, and build elaborate societies. But when did language evolve? We can't dig up ancient voices, we have to infer it from other evidence. The shape of the hyoid bone, a bone in the throat associated with speech, the size of certain brain areas like Broca's and Wernicke's areas, and the complexity of tools and social structures are all used as indirect evidence. Some researchers believe that a form of language might have existed as far back as Homo erectus, allowing them to coordinate hunts and teach toolmaking. Others argue that fully complex language only appeared with Homo sapiens, enabling the behavioral modernity seen later. And guess what? There's evidence suggesting Neanderthals had the vocal anatomy capable of speech. So, did they talk? Probably. Was it as complex as ours? We don't know. But if they did, does that make them more human? Again, it blurs the lines. The concept of a species itself is not as neat as you might think. For animals that reproduce sexually, the most common definition is the biological species concept, a group of individuals that can interbreed and produce fertile offspring. But this is hard to apply to fossils. We can't breed two fossil bones. And as we've seen with Neanderthals, even if two groups can interbreed, it doesn't automatically mean they are the same species if they have distinct evolutionary paths and unique characteristics. There are other species concepts. The morphological species concept defines species based on physical characteristics. If two groups look significantly different, they are different species. But how much difference is significant? This is subjective. The phylogenetic species concept defines a species as the smallest group of organisms that shares a common ancestor and can be distinguished from other such groups. This is often used in paleontology, but can lead to a lot of species being named. Different scientists often lean on different species concepts, which naturally leads to different conclusions about who is human and who isn't. Let's consider the chronological aspect. Where do we put the starting line for humanity? Is it when the first Homo species appeared? That would be around 2.8 million years ago, with things like Homo rudolfensis or Homo habilis. Their brains were bigger and they made simple tools, or is it with Homo erectus, who showed more complex behaviors and spread out of Africa? That's about 1.9 million years ago, or maybe it's the point where our direct ancestors, Homo heidelbergensis, started to emerge around 700,000 years ago, leading to both Neanderthals and Homo sapiens? Or is it when anatomically modern Homo sapiens first appeared in Africa around 300,000 years ago, even if their behavior wasn't fully modern yet? Or is it much later when behaviorally modern Homo sapiens started producing art and complex culture, maybe 70,000 to 40,000 years ago? Each of these points has arguments for it, and scientists will choose their preferred starting point based on which criteria they value most. If you value tool use, you might start with Homo habilis. If you value a combination of large brain, wide geographical spread, and complex tools, you might pick Homo erectus. If you value art and symbolic thinking, you might pick much later Homo sapiens. This isn't just an academic exercise. The way we define human can have broader implications. It affects how we view ourselves, our place in the natural world, and our relationship to other species. If we define human very narrowly, as only Homo sapiens, it emphasizes our uniqueness. If we define it broadly to include Neanderthals and Homo erectus, it suggests a more gradual, shared evolutionary journey with our extinct relatives. And then there's the philosophical side of it. Science tries to be objective, but the word human itself carries so much meaning for us. It's tied to our identity, our ethics, our sense of self. It's hard for scientists, who are, after all, humans, to completely detach from these cultural and personal understanding. So, a scientist might lean towards a definition that either emphasizes our distinctiveness or highlights our continuity with other life forms, sometimes unconsciously. Think about the implications for the future. As we develop artificial intelligence or explore genetic engineering, the question of what makes something human might become even more pressing. If we create an AI that can think, learn, and feel in ways we consider human, is it human? If we genetically modify another primate to have advanced cognitive abilities, would it be human? These are not strictly questions for evolutionary biology, but the debates within evolutionary biology about defining human provide a framework for thinking about these future challenges. So, where do we stand today? Most scientists would agree that Homo sapiens is a distinct biological species. That's not really debated. But when it comes to the broader question of what is a human in the context of our evolutionary past, how far back do we extend that label? Which extinct species truly deserve it? Oh, there is no single agreed upon answer. Some lean towards including all members of the genus Homo as human, acknowledging the diversity within that group, much like all Panthera species are big cats. This makes the term human a broad, inclusive category. Others prefer to reserve human for Homo sapiens alone, emphasizing our unique combination of traits, our specific evolutionary path, and the cultural and cognitive complexities that, for them, truly set us apart. They might call other Homo species hominins or archaic humans, but not human in the full sense. And within those broad camps, there are endless nuances. One scientist might prioritize brain size. Another might prioritize tool complexity. Another might prioritize evidence of symbolic thought or abstract art. Because the fossil record is incomplete and interpretation is always involved, there's plenty of room for different viewpoints. New discoveries constantly shift the conversation. A new fossil, a new genetic analysis, a new interpretation of an old artifact can change everything. It's important to understand that this disagreement isn't a weakness in science. It's a strength. It shows that scientists are actively grappling with complex questions. They are testing hypotheses, challenging old ideas, and seeking more complete answers. They are not just blindly accepting dogma, it's a dynamic, ongoing process of discovery. The lack of a single, universal definition for human among scientists, especially in the evolutionary sense, isn't about confusion or incompetence. It's about the inherent messiness of evolutionary history. Life doesn't evolve in neat, pre-labeled boxes. It's a continuous branching process. Our human story is a story of gradual change, of populations merging and splitting, of traits appearing and disappearing, and of very, very close relatives walking the earth alongside us, sharing some of our traits but not others. So, no, all scientists do not agree on what a human is when you look at it through the lens of evolution. And that's fine. It's part of the exciting challenge of understanding where we come from. They agree on much of the evidence. They agree on the general framework of evolution. They agree we share a common ancestor with other apes. But how you draw the lines, how you define the thresholds for humanness when looking at millions of years of our family tree is where the interesting debates happen. It makes the journey of discovery even more compelling.